Hello, welcome back to today's lesson. So, today we are going to solve this question. This question actually falls under DC circuits. So, the question is from the circuit below. So, that is the circuit. We have to calculate the total resistance, that is A, B, total current, C, current in each resistance, D, voltage across each resistance, E, power across each resistance, and then the last one, F, total power. So that is the circuit. The circuit is having resistance R1 and then R2 connected in series across a supply of what? 20 volts. Okay, so this is a series network. Okay, so one thing that I want you to remember is whenever you are dealing with a series network, the current is always common. Okay, the current is always common. All right, so first thing that we are going to do is to write our data down. Okay, so the data, so we have resistance R1 to be what, 5 ohms. Then we have resistance R2 to be 10 ohms. Then we have our supply voltage, that is VT, to be what, 20 volts. Okay, please make sure you subscribe to the channel. Okay, so let's move on with the solution. So A, we have to calculate for the total resistance. Okay, that is RT. So since it's a series network, we add the resistance. Okay, so we have RT equals R1 plus R2, which is 5 plus 10, and that is going to give us what, 15 ohms. So total resistance RT is equal to what, 15 ohms. I hope you're following it. Then B, we have to calculate for the total current, that is IT. So by Ohm's law, we know that current is proportional to the voltage and inversely proportional to resistance. Okay, so IT, which is the total current, is equal to VT over RT. VT is the supply voltage, then RT is the total resistance. Okay, so total current is equal to what? The total voltage over the total resistance, and this is equal to what? 20 over 15, which is 1.33 amps. So the total current is equal to what? 1.33 amps. I hope you're following it. All right, so let's move on to C. We have to calculate for current in each resistance. Current in each resistance. All right, so I explained earlier that since it's a series network, the current is common. So the supply current will be the same current that flows through resistance R1, and it will be the same current that will flow through resistor R2. Okay, so IT is equal to I1 is equal to I2, and this is equal to what? 1.33 amps. I hope you understand. All right, so let's move on with D. D, we have to calculate for the voltage across each resistance. Voltage across each resistance. All right, so the supply voltage, VT, is equal to what? The supply current times the total resistance. VT is equal to the total current or the supply current times the total resistance. So therefore, V1, that is the voltage across resistance R1, is going to be I1 times R1. That is the current that is flowing through resistance R1 times the resistance itself, that is R1. Okay, and this is equal to 1.33 times 5, which will give us what? 6.65 volts. So the voltage V1, that is the voltage across resistance R1, is what? 6.65 volts. I hope you understand. All right, so V2, that is the voltage across resistance R2, is equal to I2 times R2, and this is equal to 1.33 times 10, which will give us what? 13.3 volts. So voltage across resistance R1, that is V1, is what? 6.65 volts, and then the voltage across resistance R2, that is V2, is also equal to 13.3 volts. Please make sure you subscribe to the channel. Okay, make sure you subscribe to the channel. All right, so let's move on to E. So E, we have to calculate for the power across each resistance. Power across each resistance. All right, so PT, that is the total power, is equal to the total current times the total voltage. total power is equal to what? The total current times the total voltage. So therefore, P1, which is the power across the resistance R1, will be I1 times V1. That is the current that is flowing through resistance R1 times the voltage across resistance R1. Okay, will give you the power that is across resistance R1. I hope you understand. So this is equal to 1.33 times 6.65, which will give us what? 8.84 watts. So the power across resistance R1, that is P1, is what? 8.84 watts. So let's calculate P2. That is the power across resistance R2. And this is also equal to I2 times V2. That is the current that is flowing through resistance R2 times the voltage across resistance R2. Okay, all right. So this is equal to 1.33 times 13.3. And it's going to give us what? 17.69 watts. So P1, that is the power across resistance R1, is what? 8.84 watts. And then P2, that is the power across resistance R2, is also equal to what? 17.69 watts. I hope you're following it. So let's solve the last one, which is what? F. And we have to calculate for what? The total power. So we can use this formula. PT, that is the total power, equals the total current times the total voltage. Or we can also use PT, which is the total power, equals the power across resistance R1, which is P1, plus the power across resistance R2, which is what? P2. So P1 plus P2 should give you the total power. Okay, all right. So let's take the second formula, that is PT equals P1 plus P2. Okay, so this is equal to what? 8.84 plus 17.69. Okay, so when you add, you are going to get what? 26.53 watts. So the total power, that is PT, is equal to what? 26.53 watts. Thank you so much for watching the video, and please make sure you subscribe to the channel. Okay, so I'll see you in the next lesson. Thank you.